My name is Neil Sendas. I'm a Principal Technical Account Manager at AWS. And I'll be joined by my colleague, Stephen Dolan, who's a Migration Services Specialist. And we also have a guest speaker from Georgia Pacific, Carlos Wiley. Carlos is an enterprise solution architect at GP. So here's the agenda. We're going to talk about application cloud modernization challenges that we hear from our customers. We're going to talk about refactoring applications and some of the best practices and patterns. And then we'll look at two services, AWS Migration Hub Refactor Space and AWS Resilience Hub that can help you fast-track some of these initiatives. And then we also do a demo and then hear from Georgia Pacific about their journey. Let's get started. So in recent years, compute has undergone a major shift towards containerization and serverless as customers seek business agility and operational efficiency in the cloud. As you can see in this graph, we all started with on-prem, where our ability to innovate was fairly limited to our capacity to plan, rack and stack servers to meet that plan and demand. And then as we moved to containers and serverless, developers achieved greater degree of mobility and agility because serverless and containers help you achieve platform independence and fast track your deployment. Now, which in turn would reduce your total cost of ownership and overall increase your pace of innovation. But this path of modernization from on-prem to virtualization to all the way up to serverless is not easy. There's a lot of challenges along the way, and that we have been hearing from customers, and we're going to talk about two of them here today. The first one is modernizing those legacy monolithic applications. So monolithic applications are those large applications that have been there for ages, that hardly been any new innovations or new changes in these applications in the recent years, but they do perform some very critical functions for your business. They are very difficult to manage and maintain because most likely the developers are no longer in the team. They have moved on to other roles, and there's very limited domain knowledge about these applications. There's a couple of limitations with this. The pace of innovation is slower on those applications because product teams have to really plan well in advance before making any changes, because as you make changes, you have to deploy that change for that monolith all at once, which delays your time to market, because any changes, any deployments have to be planned in advance, well ahead in advance for months and coordinated with multiple teams. On the technical side, most likely these applications have tight couplings. When there's a change, this change could impact the application layer, the database layer, so all these IT teams have to be there together working synchronously to make sure that this change goes through successfully. There's hardly any scope for experimentation in these environments. And then when there's an issue in these monolith, it takes time for you to recover from these outages. So how do we modernize these applications? And customers' application portfolios have hundreds of these applications still around. So one option is to modernize this by converting them into microservices, where you take this monolith, break it down into multiple microservices, where each of these microservices addresses one of these functionalities. You are going to achieve a reduced blast radius by doing that, because now you're controlling the functionalities and any changes will be limited to that function. You're going to achieve functional autonomy. Individual teams can now function independently. They don't have to coordinate before a release. You can achieve deployment velocity because you're going to deploy faster because you're deploying incrementally now. And then you're going to be able to do targeted scaling. Earlier, when you had to plan for a scale-up event, the whole monolith had to be scaled up at once. Now, with microservices, you could auto-scale maybe one particular microservice that you're expecting to receive more traffic. So it helps you with that as well. Now, this incremental refactoring takes time. It's expensive, and since the developers of those monoliths are no longer around, most likely, the knowledge that the team has to carefully convert these monoliths to microservices is limited. And that again slows down the process of modernization. And then there is this undifferentiated heavy lifting of creating this refactor environment, which includes creating these multi-accounts where you'll have all those microservices. You're going to have to create those VPC routes so that you could carefully route the traffic from one monolith to microservices. There's several challenges like that. Now, over the years, what we've noticed is that this is the stage of your modernization journey where things either stall or slow down significantly. So there are some best practices that you could follow. There are two patterns we are talking about here. One's strangler fig, and the other one's leave and layer. The first one, strangler fig, Martin Fowler introduced us to this pattern where instead of taking a big bang approach of converting this monolith to microservices, take a more tiered approach. Take one or two functionalities that add greatest customer value, convert this into microservices. What you're going to achieve by that is you're going to have a reduced blast radius, you can have incremental refactoring, you could reduce the amount of dependencies on other teams. Then there's leave and layer. What leave and layer does, instead of making changes to your existing monolith, add new functionalities and set them beside your monolith within this refactor environment so that any hit to your microservice or the new feature goes to your microservice, and then the existing traffic will be routed back to your monolith. And all of these changes are transparent to your customer. They're very seamless, that they are not even aware of these changes that's happening. So that's leave and layer. So you're leaving your existing monolith and layering additional functionalities on top of it. So it helps you increase your pace of innovation because, again, you're reducing your blast radius. So after listening to all of these pain points that our customers talk to us about, we released a new capability within the AWS Migration Hub service called Refactor Spaces. So what Refactor Space does is it fundamentally changes the way you approach these incremental refactoring modernization initiatives. It does all that undifferentiated heavy lifting I mentioned. It creates this multi-account refactor environment for your microservices. It helps you break down this monolith and create smaller microservices and then reroute traffic incrementally to those microservices. You can also add new functionalities and leave the existing monolith as is. So all of this within this refactor environment and very seamless to the customer. We're going to do a deeper dive into how this service works under the hood and also provide a demo. But before that, what's the other challenge that we have heard about? So once you're further along in your modernization journey, you got your monolith, you lifted and shifted it to the cloud, and then converted into microservices. Now, the other big challenge is how do I build a more resilient application infrastructure in the cloud? So resiliency is the ability of an application to recover from outage. It's measured by two industry standard metrics called RTO and RPO. RTO is recovery time objective, which is how long can your application sustain outage, or how much downtime can your business withstand and still not don't have a major revenue loss, right? RPO is how much data loss can your application withstand. So here's a challenge, right? Back in on-prem environment, things were fairly straightforward. You had a primary data center, you had a secondary data center, and in the event of a disaster, you would initiate a failover and you'd reroute traffic from your primary to your secondary. And you would perform a DR exercise once or twice a year, measure your RTO, RPO, and things were, of course, I'm overly simplifying things here, but here's the contrast in a cloud environment. It's much more distributed, and you have many AWS applications, and these AWS services have their own redundancy, resiliency, durability targets. How do you make sure that my overall application is resilient? And as I make incremental changes along the way and make changes throughout the year, did I break any of that? Do I still meet my RTO, RPOs? Or do I have to wait for my annual DR exercise to find that out? For business-critical applications and mission-critical applications, this is a significant drawback. And some industries, it's a compliance issue as well. Now, there's another challenge. An application portfolio of a large organization typically has hundreds of these applications. And how do I manage the resiliency of my entire application portfolio at scale? Can I manage the RTO, RPO of all of my applications? See where are all those incremental changes happening? How are they impacting my RTO, RPO targets? And can I make sure that I know about these changes before it's in production and it has an impact on my infrastructure as well? So these are some of the challenges that a new service, AWS Resilience Hub, addresses. It's an application service that was launched in November of 2021. What I mean by application service is, your business application consists of multiple AWS services. And together, they perform a business function and helps you create an application out of that. So let's take an example. You have an SAP application. It could be as large as an SAP application, or it could be as small as a microservice behind an API gateway. So you define your application, and then what Resilience Hub does is, it helps you, first of all, you can define these application itself within your Resilience Hub using something called a resiliency policy. And then it helps you define, validate, and track the resiliency of our application overall. So what it does is it assesses the application and its single point of failures. When you define a resiliency policy, you provide its RTO, RPO targets. And then during the assessment phase, it reviews these. And the way it does is it's very seamless. It doesn't test against your endpoints or hit your endpoints as such. It uses the metadata in your resiliency configurations to assess whether you're going to meet your RTO, RPO or not. Let's give you an example. Let's say you have an RDS instance, which is a single AZ. And in your resiliency policy, the target RTO for that is 15 minutes. Now, during the assessment stage, it will look at your metadata, and if you don't have a read replica, most likely you're trying to restore it from your backup in case of a failure. And it'll take you more than 15 minutes to recover from a backup. So clearly, you're not going to meet your RTO, RPO needs. So it's going to let you know that you're going to miss your RTO targets, and it's going to provide you resiliency recommendations. For in this particular case, it'll let you know that maybe you should have a read replica in a different AZ, or add another AZ to your instance, or maybe try Aurora Global for multi-region. And then it'll give you some cost estimates of how much additional cost you have to incur because of this additional resiliency that you have added to your infrastructure. Additionally, it will also tell you about your operational readiness. So it'll look at your monitoring and measurement and observability metrics and see if you are monitoring the right metrics or not. For instance, are you monitoring the CPU or memory utilization? It'll help you create alarms and alerts in case you don't have those, so that you can get those initial signals to make sure that your applications and infrastructure is not impacted, right? It also helps you create standard operating procedures, which is, think of it as runbooks. You can create runbooks on how your application will react in case of a failure. This can be executed through with an integration with SSM agents. And then you can also run fault injection checks. So fault injection simulator is our chaos testing tool. You can create simulations and see how your application not only behaves during these events, but also how it recovers. Couple of benefits of Resilience Hub. It helps you manage your RTO, RPO at scale across the entire organization and your application portfolio. You could integrate Resilience Hub with your CI/CD pipeline, which helps you identify if maybe a new change that you have introduced, before even the change is introduced, in fact, you could run these reports and see if that change might impact your RTO needs or not. You could also audit which particular change introduced a delay or breached your RTO, RPO. So overall, it helps you manage the resiliency strategy of your entire organization at scale from a single console. So now I'm going to hand it over to Steven to give you a little deeper dive into how these services work, what is under the hood, and he'll take over from here.
Thanks, Neil. Hi, everyone. I'm Steven Dolan. I'm an AWS product specialist, and I work with both Resilience Hub and Refactor Spaces. So Neil did a great job of giving us a high-level overview of both of those. A little bit deeper right now, go under the hood a little more, and also give a demo through the console of both of those. And hopefully that'll help tie things together. Great, so looking at Refactor Spaces first, think of orchestration, right? So Refactor Spaces orchestrates several AWS services on your behalf. I want to highlight the Transit Gateway here, right? So Transit Gateway helps bridge that network connectivity from your new microservices to your existing monolith, right? So you're going to have those attachments created for you to that Transit Gateway as that networking hub, basically to allow communication from old to new. Resource Access Manager, RAM, is used to share resources, right? It shares that Transit Gateway with those other AWS accounts in your Refactor environment. RAM is also used to share the actual environment itself, right? So when you add these maybe new microservices in, which we'll go through in a second, that live in other accounts, they'll see that Refactor Spaces environment as a whole. Right, also importantly, API Gateway, right? This will serve as this new front door to the application. So Neil discussed Strangler Fig previously, right? The important part there is you get a new front door, a new endpoint to the application that doesn't change, right? What does change is everything behind it, right? As you're adding new microservices, maybe new routes, the consumer doesn't really feel any of those changes since you have the same endpoint, right? And also we have Network Load Balancer. This helps route that traffic to private IP addresses within your environment, right? So you could have public-facing things and also private IP addressed resources, right? And it uses something called VPC link, which I'll go through in a second. All right, so here I'm going to walk you through Refactor Spaces, just the creation of an environment, what that looks like. And we'll start with the environment creation. We'll add some accounts. We'll then create the application, right? Services, and finally routes. So let's see what this looks like. Great, so first we create our environment. We recommend you do this in a single dedicated account, actually. We call this account the environment owner account. And that provisions or orchestrates that transit gateway in that account, right? And so keep in mind this environment owner account is going to hold all these networking resources I mentioned previously. This is where they're going to go. Right, so we create the environment, then we have the option to share that environment with other AWS accounts, right? The accounts that are involved in this refactoring that we're doing, right? In this example, we have our monolith, like let's say you lifted and shifted our monolith. The example there is on the bottom. And then we have another account here for a new microservice, right? So multiple accounts here add that isolation, right? Gives that team independence, right? And it helps drive or reduces that blast security blast radius, right? So in this account, simple example, we'll show 3 accounts. Usually recommend this is sort of the starting point, right? We have our environment owner, we have where the existing app resides, and we have the new microservice. Do keep in mind, which I'll cover a little bit more, if your monolith is on-prem, that's also possible to do some routing. It's a little bit more manual networking there, but it's still possible to link up to that transit gateway if you like. All right, so we have our environment. We shared that environment. Also, another note, this environment can be shared as you go on. So initial creation, we have shared the environment with other accounts. As we might have more microservices in other accounts, we simply add those in as we go along. So something you can do at the beginning and in the future. Great, so now we create this application, right? This is what stands up that API gateway, that new endpoint, right? That new front door that stays the same as everything else behind it might change in the future, right? We have network load balancer there. That's to help that routing again to private resources, whether it be in the monolith account, the new microservice account, or any other accounts we might have. Great, so finally we're ready to create our services and routes. So services is that business functionality, right? So service 1 would be your monolith, right? This is the first step. Create the service for the monolith, and then add a route to that monolith. So this is the path-based route. So step 1, what we're going to do is we've added our monolith in. We've added a default route that's going to catch all traffic. Right, so what we've done here is we're going to prove that through this new front door, through this new API gateway, we can still test that functionality. Everything's working as expected. Right? We've yet to add a new microservice, but we're ready now at this point. So now we have our new endpoint. The service for a monolith has been created. Now we're ready to add a new service for our first microservice. So I'd like to give an example here. Let's imagine the shopping cart functionality of an e-commerce store. We pulled that shopping cart functionality out. We'll call that path/cart, right? And we can create a new route /cart would go to the new microservice. In this example, we're using Fargate, but this could be any AWS compute that we'd like. And as you'll see in a second, when we add these endpoints, they can be HTTP endpoints or Lambda functions. Right, so, and this is the process, right? We have our environment, again, we have that endpoint there. As we add more microservices, more and more traffic, right, is going to these microservices, less and less traffic is going to that monolith, until essentially we can look to possibly retire that monolith over time, right? But that's that incremental fashion we're doing things. A lot of risk is taken out here rather than that big bang, right? If we maybe want to back out, remove one of these services, go back to the monolith, we can easily do so, right? Our endpoint doesn't change, we just simply change it on the back end. Great, and you'll see all of this, what an environment looks like in the console here in a second. Great, so let me shift it for a second here to Resilience Hub. And you'll see the same thing in the demo, right? We're going to add an application and assess it, but this is stepping through the process of Resilience Hub. So step 1, right, we're going to define that target. What's the measuring stick? What's the RPO, RTO? And we define that also for 4 types of disruptions, right? Which is nice, right? There's different types of applications. You may have different considerations. Regional is optional, right? Not every application is regional, but you can set a regional RTO, RPO. There is an application disruption type, right? Maybe you had a bad deployment where you've overwritten an object that you need to recover. You can set RTO, RPO for that. AZ issues, right? If one availability zone may have an issue, how will you recover? And finally, there's an infrastructure piece, right? Maybe one EC2 instance has an issue, maybe an RDS instance has a problem. You set RTO, RPO for that. So great, we have our target, we have our measuring stick. Next step is to add the application. This essentially is describing the application to Resilience Hub, right? What's it made of? It's not going to impact the application. It's basically reading what services make up your application and how's the resilience set for these services. So we add our application, and this can be done a few ways. You can use resource groups, tag-based resource groups. You can use CloudFormation stacks, right, up to 20 of those, and also Terraform state files. So we describe the application, now it's time to assess it. So the assessment will take just a few minutes. I'll actually run it in my demo. It'll be in real time to show you how fast it is. It's not something that churns for hours, right? It runs pretty quickly, assesses that application, and gives recommendations. Right, so the flow is you define your target, you've added the application, you've assessed it, and you'll probably get some recommendations. From that point, we hope that you take those recommendations, you make some of those changes that are recommended. On top of that, right, we have those operational recommendations, setting up those alarms to detect if there are any issues, right, CloudWatch alarms. You also have those standard operating procedures, right, recovery procedures that I recommend you set up. And also testing, right? That's the verify portion. It's very important, right? It's one thing to kind of guess what your RPO will be, but the verify is actually injecting that fault and really verifying, okay, it may take this long to recover, this is the impact, and hey, our alarms are also picking these things up. And finally, we can track that posture. We have something called a resiliency score, which I'll go into in a second. But what that is, it takes into account, are you meeting your targets? And are you actually implementing some of these recommendations? Are you verifying through fault injection simulator? And that'll increase your score, or it may decrease depending if you haven't done that in a while. That's just a good way to keep in mind, all right, if maybe your score plummets from one week to the next, what changed in the application, what happened there? It's a good indication to go back and take a look. All right, so I'm gonna go through a few demos here. We'll start with the Refactor Spaces and then do Resilience Hub. But for the demo of Refactor Spaces, I'm just going to show you what an environment looks like and how we maybe add a new service into this environment. So the demo here is going to show you just what you saw previously, right? We have one environment. We have one application in this environment. We have a few services, right? We had a monolith service that I created first. And our first, the new service is that first new microservice, right? The second service. And then two routes, right? Default route to the monolith and one new route to the first microservice I have. So it's following that same pattern there. All right, I'll talk you through this. So we can go to Migration Hub to access Refactor Spaces. We can also type in Refactor Spaces here directly to get to it. But in this case, I'll go to Migration Hub. On the left, we'll find Refactor Spaces. Awesome, so we see here we have one environment, right? We have two other accounts in this environment. This is sort of the high-level dashboard of what's going on. So let's take a closer look in this environment. You see on the right, we have that transit gateway that we stood up, as mentioned. We also have one application. We'll also see here in a second, the Shares tab will show me the accounts I invited to the environment. You'll see it says associated there. That means they accepted the invite through RAM, right, to be a part of this Refactor environment. We have the account numbers listed there also. And the Networking tab will show me the VPCs that are in play in this environment, right, that are linked to that transit gateway to allow that communication across accounts. And also we have our services and routes, right? As mentioned before, the monolith and the first microservice, and we'll go into a little more detail on that in a second. So let's go into the application. And we see that proxy URL, right? That's the path to that new front door. That's not going to change. That shields the consumers from any changes on the back end, right? We have our endpoints, right? HTTP endpoints in this case. And walking through a service creation to show you, right? You have these two options. You name the service. You select whether it's a Lambda function or VPC, right? Select that VPC to add it to that network fabric in the environment. And you also specify the endpoint, the HTTP endpoint here. And finally, you have your path, right? Your path and your method or verb that makes those changes on the API gateway, which we'll see in a second. Great, so let's take a look in the API gateway to show you, right, the changes that were made on it. In this case, I did not touch the API gateway on its own, right? I did all this through Refactor Spaces, and you see the paths, the resources here, the methods were all done for me. It's worth noting here too, right? These resources are in your account, a transit gateway, API gateway. If you want to peer that transit gateway to another one, you can, right? You can touch these things. You can go to the API gateway, put a WAF in front of it if you'd like, resource, access control, you can also apply those things you usually do. So those resources are in your account, they're not under the hood and not untouchable or anything like that. You can actually modify to an extent any of those resources. Awesome, so switching to Resilience Hub. So this demo, very simple. I believe this is a WordPress application, single availability zone. Probably you could guess I'm going to get flagged on a few things here, more than a few things. RDS instance and one AZ. Same thing for EC2 instance. We only have one NAT gateway, one S3 bucket. So Let's run this through an assessment and see what it tells us. Great, so I'm going to access Resilience Hub here just by typing it at the top. It can also be found in Management and Governance section of the console. So here we see our dashboard. We have a place to track that resiliency score I mentioned, up to 4 applications over time. So that would populate in this screen here. But for now, let's go to Applications, and let's add an application. So first things first, we're going to describe the application. In this case, I have a CloudFormation stack. Again, you could fall back to tags, right, through resource groups if you'd like. In this case, I'm going to choose my stack. And have the option to do this across account or across region if you'd like to, so it's a possibility. I'm going to name the application. And you'll see there's an option here to do a scheduled daily assessment automatically. I'm just going to flag to turn that on and go to next. Now it's identifying the resources, right? It's reading what this application is made of. As I mentioned, this just takes a few seconds. But we're going to see all the components of this application. We have the option to exclude things if we'd like, so there's some flexibility here to only assess what you want. It shows us the account, the component type as it categorizes into different things like database or storage. But if everything looks good here, I can go to next. Great, now we'll choose our policy. I'd created a pretty aggressive, I think, 5-minute policy just to show you an example here, but this is where we select that, right? That's that measuring stick, that target we want to meet. And we'll go to next. And this is just the summary page of what we selected before, and we're going to publish. Sorry, so publish means the app's been described to Resilience Hub. We have our targets. Now we need to assess as the next step. So I'll run this assessment where I recorded this is actually in real time, so I didn't speed anything up to show you. It takes under a minute here. But first thing, I can name my assessment if I want for the report, or leave that as default. And you see in the status there, it's pending, so it's assessing. And you see there in the tabs, you have the alarms, SOPs, fault injection. That's the operational stuff we'll go through in a minute, right? But you also see the workflow at the top, just to give you a follow along, right? We publish the app, we assess it, then we set up those recommendations. Those alarms, the fault injection experiments, we run those experiments, and that's the workflow that you continually go through. All right, it's just about to finish up here. And then you see success at the bottom, policy breach, no surprise there, right? If you're looking at the architecture diagram before. Let's take a closer look. In results, this is just a very high level if we're meeting our targets or not for the different disruption types that we have. Not surprisingly, there's a lot of stuff that's unrecoverable, right? It's 1 AZ, no backups are configured. We can highlight over these things here to see more detail, right? So in this case, we have our storage component, right? No versioning, no Glacier turned on. We also have database, no backup. Same thing for AZ here, right? Auto-scaling group, we only have one availability zone we're using. And also NAT gateway, we only have one of those. So this is the high-level results, but what's nice to see here is also the recommendations. So we'll go into that next to see what it recommends we do to meet those new targets, or those targets that we had set. So here we see it divided by different categories, right? Compute, database, networking. Let's take a look at database. It's optimized for cost. There's different options here, right? To meet those targets in different ways. You maybe want to max it out. Maybe you want to keep cost in mind as much as possible, or make minimal changes. It tries to categorize those for you. So networking here, right? It mentions to add another NAT gateway, not surprisingly. And into the S3 bucket, right? It's going to mention to turn on versioning. It's important to note this is not automate. You still have to go back and make these changes. There's no, say, one push of a button, but there's considerations here to make, obviously, when you do something like that for these architectural decisions. Now we have our operational alarms. This is nice because you select the ones you want to deploy. It will create a CloudFormation template for you. You can deploy those and you're off and running. So it's not just recommendations, it also gives you a template to deploy. Same thing for the SOPs, right? These recovery procedures through SSM documents, and same thing for the experiments. Right, so by just selecting the ones you'd like, you create the CloudFormation template. Some do require a little more configuration. If they do so, you'll see there it's marked configuration. You might have to say install an agent of some kind. It'll tell you how to do that also. Great, so that's Resilience Hub. right? It gives you the recommendations for the architecture, and more importantly too, well, also importantly, it gives you the operational things, right? Detecting disruption, recovering from disruption, and injecting that fault to actually simulate and verify your numbers in your RTO and RPO. With that, I'll hand it to Carlos to speak about Georgia Pacific and their journey.
Thanks, Stephen.
Yeah.
Good afternoon, everyone. My name is Carlos Wiley. I'm one of the enterprise architects here at Georgia Pacific, with my main focus being in cloud modernization, disaster recovery, DevSecOps, as well as our enterprise training program. So I've been with Georgia Pacific for 4.5 years now. I've been with our parent company, Koch Industries, for 10. And for those who do not know, Georgia Pacific is one of the largest manufacturing companies when it comes to producing building products, packaging, cellulose, as well as consumer products. So you might have seen some of our paper towels or tissue in the stores. And GP, like many companies, decided to move to the cloud. And when we did this, we did a lift and shift, and the goal was to modernize once we got to the cloud. Now we're looking to get to that better desired state, and here are our two main initiatives that we're working towards. The first one is application modernization, and the second one is building more resilience infrastructure in the cloud. So what I'm going to do here is first cover application modernization in those three initiatives, the work that we did with one of our applications, and how we partner with AWS Refactor Spaces to help accelerate that program. And then I will come back to this slide and cover the work that we're doing with our DR strategy in making our applications more resilient. So when we look at modernization, the first thing that we really want to do is to start to refactor those lift and shift applications, move away from those EC2 instances, and more towards microservices. One, to allow GP to be more scalable when it comes to demand, but also to reduce the technical debt that our developers are getting today with those EC2 instances. And as we're modernizing, we want to also make sure that we're building it in a consistent manner. So we want to start creating more infrastructure as code modules with our GP cloud standards, as well as security standards embedded to reduce the inconsistencies we see today with those manual deployments. And then lastly, as we are looking to modernize, we want to start segregating our applications from each other with dedicated accounts. So you might hear me say micro accounts throughout the presentation, and that's really taking either a team or application specific and putting in its own account, really to reduce that security exposure in a case of an incident, but also to give our developers more flexibility and ownership within that account. So overall, those are our three main initiatives when it comes to modernization. And when we were first looking to test that out, we had an application called Wood Duck, and we really wanted to see if those were the correct things we should be targeting. So Wood Duck is a web application. This was lift and shift from our on-prem data center, and its main function is to sell, purchase, as well as quote out the price of lumber for our developer or for our users. And as you can see, it's very monolithic by design. We have all of our APIs running on that one app server. So as we were looking to modernize this, we knew we wanted to move to containers and more microservices. But we wanted to do it in a way to where our application server was not impacted. So we decided to implement the strangler fit pattern of slowly decoupling that to allow us to slowly get to that termination state. So in the case for this POC, we went ahead and worked with the developer to get that buyer API, containerize that, and then we were ready to move on to our next step. The next thing we wanted to do when we were looking at this was to make sure we can have this deployed in its own dedicated micro account, and then would it be any impact to our customer experience when it comes to latency. And this is really when we started to look at Resilience Hub, Refactor Spaces to help with the traffic so that no matter where our customers are coming from, we're directing it to the correct microservice and not our Wood Duck application. And then finally, as we were looking at this, we wanted to also deploy this in an automated fashion. So in the case of having our standards in place, but also to, if we ever needed to destroy this and recreate that POC environment from scratch. So with that in mind, we went ahead and did this proof of concept with Refactor Space, and this is what our end state looked like. So we were able to successfully move that buyer API to an EKS cluster and have it running in its own dedicated account. Due to the fact that we decoupled this from our wood duck application, our wood duck application, the application itself was not impacted. The next step was, when we put it in our own micro account, we were able to show that the customers also weren't impacted. So behind the scenes, Refactor Space was looking at what path the customers were coming in as, hitting, and then it would direct all new traffic to that buyer API there. And then finally, we were able to successfully deploy this through a CI/CD process, as well as infrastructure as code, utilizing AWS Proton, which has helped us when we needed to just quickly destroy that and add on to it. So overall, this was a really good POC. We saw the benefits of Refactor Space, and now I really want to highlight some of the higher ones. So what we have here, the first 4 are really geared towards the fact that we moved that API to a microservice. And working with our developers, we were able to increase that productivity when it came to making changes with that barrier API. The next, we were able to start moving to daily releases from the previous ones when it came to that, as well as decreasing the failure impact, since this is now decoupled from the wood duck application. The last one around microservices is that application composability. And that's really allowing our developers the flexibility to use whichever programming language or whatever microservice technology that they wanted to use for the best use case for their APIs. And then finally, we have increased speed of deployment when it came to the networking of our VPCs, the API gateway, as well as the transit gateway by 90%. So if we were to do this by ourselves, that would take us on average 5 to 6 hours, and that would be per application we were looking to set this up for. With Refactor Spaces, we were able to do that within 20 minutes, and it's able to scale across multiple applications. So with that in mind, what's really next for Refactor Space and Georgia-Pacific? So we're looking to drive adoption of this service within GP as well as Koch to have this as an option as teams are looking to modernize to help accelerate that initiative. The next one is to start developing more infrastructure as code modules on those most common use cases for microservices to make sure that we're building in a consistent manner. And then finally, as we continue to modernize throughout our environment, we want to look for opportunities for reusability to help us reduce some of our application portfolio or help teams that are just starting out accelerate their modernization as well. So with that, I want to go back to my first slide and now bring attention to building resilient infrastructure in the cloud. So one of the main things that we want to do is reduce that time spent on our DR prep, process, and testing. We've noticed that developers would deploy infrastructure to get around the cumbersomeness of this to save time when it comes to DR. So we really want to reduce that to push them in the right direction. And the next one is really going back to that modernization effort. So as we're looking to modernize more, we want to make sure that we have a process to test serverless applications. As I stated earlier, we're very EC2 focused, so using replication tools has helped us in the past, but as we move to more microservices, we need to have a plan to move forward with that. So now I want to cover what our DR state looks like without Resiliency Hub, cover some of the challenges, and then show you what it looks like with the tool in our environment. So as you can see here, at GP, we have a continuous cycle when it comes to our DR, and we do this once a year for all of our applications. So we start off with that technical assessment, and that's really defining your components of your application and all the infrastructure for it, determining your tier, and then validating that your application can hit that tier's RTO and RPO, as well as hit its AZ requirements as well too. So some of the challenges we have with this today is that this is manual. So a lot of times developers would miss some of those components of their AWS infrastructure, but also too, when it comes to remediating it, they would also miss those steps due to the lack of knowledge there. Once we get that technical assessment completed, we move over to creating that DR plan. And the main thing here is that this is a blueprint of how to recover your application in the case of an incident. And we have 2 main steps in here. We have the application recovery steps, as well as our infrastructure recovery steps. The main issues that we have with this is that there's a lack of knowledge on how to test AWS infrastructure, and in that, we have a lot of gaps there. As we work with our developers to clean up their DR plan, we move over to that tabletop. And this is where we do a dry run of our DR plan to get us ready for that functional test. So the fact that those first 2 steps, we have a lot of inconsistency, that would make our tabletops either get extended from the required time there or have to reschedule that multiple times. Once we go through that tabletop and we're prepared, we move finally to our functional tests. During this functional test, we take a snapshot of production, move it to an isolated network, and then do our DR test there. While this is not a challenge today, I do just want to bring attention to it. We are still looking for how to test for serverless applications. So that's what it looked like without Resilience Hub, and this is what it looks like now in our production environments. So as you can see, the first 2 steps are the ones that really change the most. The first being that instead of that technical assessment, we now have Resilience Hub helping with that. So with this tool, we're able to catalog all of our Tier 1, Tier 2, and Tier 3 applications, either utilizing the AWS resource groups, Terraform state files, or CloudFormation stacks. We're also able to predefine all of our RTOs and RPOs of our tiers and deploy that out to all of our GP accounts. That allows our developers to no longer guess what those requirements are and just only select that based off of their tier application. And then finally, as we're doing that assessment, or rather while the assessment's running, it provides recommendations on how to resolve those issues that comes up. So we were able to reduce all the manualness of it, as well as give our developers a shortcut on how to remediate those issues in that technical assessment. The next thing that changed was our DR plan. So on the prior slide, I had that infrastructure recovery step, but now with Resilience Hub, they provide suggested steps that you should take to test your infrastructure. So this could be something as simple as deleting an object in your S3 bucket and recovering it through versioning. So our developers are now able to copy and paste that, put it into their DR plan, and has made those more consistent. Although this is not highlighted here, but since the first 2 steps are more consistent there, we have less tabletop, or rather, we have less rescheduling of tabletops and extending those meetings. So we've seen impacts to that as well. And now I just want to highlight some of the main benefits that we've seen on using this in our environment. The first one being the increased speed of delivery when it comes to assessments by 94%. So on average, when we were doing our manual assessments, that would take us on 90 minutes or so. With this, it's 5 minutes worst case. So we were able to get a lot of time back there. The next one is we were able to decrease the time spent on our overall DR process. So this includes the preparation, the technical assessment, setting up your DR plan, as well as at tabletop by 50%. And then finally, we were also able to improve our DR compliance. So this is really important. Going back to that cycle we had, if anything changed in our environment, either after that technical assessment or during the functional test, we wouldn't catch that until the following year. Since we're able to do daily assessments or whatever your cadence are for that, we're able to catch those changes and make sure that we're still adhering to those policies. And now I just want to end with what's next with Resilience Hub. So at Georgia Pacific, we're really trying to move more towards automated deployment and moving towards a CI/CD process. So we want to add Resilience Hub to our pre- and post-deployment steps to make sure that we are being compliant with everything we're spinning up. The next one is to create resilience reports that we can share with leadership to show our compliance, as well as having a resiliency score for our application. And then finally, we really want to start integrating Fault Injection Simulator into our environment to help us facilitate testing for serverless applications. And with that, I will hand it back over to Neil. Excuse me.
Wow.
Thanks.
Thank you, Carlos. That was great. So to summarize, we looked at some of the biggest challenges that our largest enterprise customers face as they go through their modernization and transformation journey. We looked at how Refactor Space can help fast-track application modernization, and how AWS Resilience Hub can help create a resiliency strategy for your entire organization and help you manage your resiliency at scale. So these are some of the challenges we just talked about. So next steps. So if you are interested to learn more about Refactor Space or Resilience Hub, please reach out to your account team. There are free tiers for both of these services. There's a 3-month free tier for Refactor Spaces and 6 months free tier for Resilience Hub. There's a couple of blogs, user guides, and videos around these topics. If you are interested, please take a look. And reach out to your account team. We can set up immersion days for you to explore these services. And we have workshops as well. Refactor Space, Resilience Hub, these are 2 examples here. But if you need customized workshops, please let us know, and we can organize that. So tomorrow, there's a workshop, Modernizing Your Workload for Speed and Flexibility. In this workshop, you could actually get hands-on with Refactor Spaces. So if you're interested, please do join us for that. There are a couple of related sessions. There's a builder session on migrate and modernize at scale. And there's a breakout session on resiliency in the cloud. So with that, I'd like to thank you all for joining us today. Please fill out the survey. Let us know how the session went if you have